Hello, welcome to Z Talk. In the last session of Docker, I explained what is Docker, how does it work. Starting this session, we're gonna start to look at Docker client or Docker CLI to learn the commands that we use to interact with Docker containers and images. Previously, I've gone through Docker run in detail. As you remember, I executed Docker run hello world to create an instance of this image. What happened was we took the snapshot of the hard drive right here in this diagram, hello world, right? We stuck it into the container right here, or you can say a group of resources, and then we executed the command hello world to kick off the process. By the way, here's the link to my previous session. Feel free to jump back there to refresh your mind how does work. All right. Now let's continue on talking about the variations on these Docker run commands. Remember, anytime that we execute Docker run with an image, we not only get the file system snapshot, but also we get this default command that is supposed to be executed after the container is created. In this case, it's run hello world right here. All right. So the variation on Docker run that we're gonna look at is gonna give you a way to override this default startup command. Here is how we're gonna do that. We issue Docker run and with the image name as what we did before. However, after that, we're gonna supply an alternative command to be executed inside of the container after it starts up. This is an override. So whatever default command is included inside of the image is not gonna be executed anymore. So let's test it out real quick. Let me jump to my terminal, and I will run these. This time I'm gonna use this new image called BZBox, and I will run Docker run BZBox, and after this I'm gonna supply a alternate command, echo welcome to ZTalk. Basically, what I'm expecting out of this command is it's gonna return me a string called welcome to ZTalk. All right, let's test it out. Hit enter. Here we go. It's basically print out welcome to ZTalk. All right, and let's try something else. Docker run BZBox. ls. Okay, here basically this time it prints out all the directories that exist inside of this container. So let me jump back to my slides. Here I draw a diagram basically to help you understand what happened behind the scene. So basically what happened was that inside of the BZBox image, right, it has some default file system snapshot and some presumably default commands, which we don't know, right? When we create a new container out of this image, we took these file system snapshot out and we stuck them in as in folder for that container, and then the command that we executed was ls, or echo welcome to ZTalk. For ls, which basically listed out all the folders in the hard drive. Now, one thing you might be curious about is why I chose to use this BZBox image here as opposed to the previous image I used for demo hello world, right? Let's go back to my terminal and I will try the same command using hello world image, and let's see what happened. So let me go back to my image. This time, let's do Docker run hello world and echo welcome to ZTalk. Let's see what happened. Okay, very quickly it returned an error message. Let's try something else. Let's try ls. oops, same thing. It basically got the same similar error message, right? So here is the issue. When I ran the alternative commands like echo or ls with busybox image, let me go back to my slides. Basically, those commands worked because ls or echo are two programs that exist inside of the busybox file system image somewhere inside one of these directories. All right, and basically that's ls or echo executable are stored over there. However, with the hello world image, the only thing that exists inside of the file system was a run hello world command. So that's basically what happened and why it returned that error message, because it could not identify these echo or ls commands. So in summary, if we're trying to issue a command that does not exist in the file system image, we're going to see that error we saw in my terminal, like here. All right. Now let's try now some other CLI commands. The first one, of course, I'm gonna introduce is docker ps. This command lists all the different running containers that are currently on your machine. Let's test it out. Go to my terminal and just issue docker ps. So far, we've only been running images that run very quickly and then close immediately. That's why we didn't see any return out of this command. So we have to have some containers that are running a little longer if we want to see some meaningful return, right? So let's try some other alternative commands that will run longer. So how about ping docker run busybox ping, let's say Google. Okay, so it's constantly ping Google here, right? So let me jump to another terminal and issue the same command, docker ps, and you can see a container with ID like this, and the command was ping. So that container is still up and running. All right, so let me stop this container and go back here, run the same command again, and you will not see anything because that container was already stopped. So if you want to see just list out all the containers, no matter it's stopped or it's still up and running, you can do that. So by issuing docker ps with an argument -a, so basically it lists out all the containers that have been stopped or are still up and running, right? So with the status right here, you can see and the images used and container ID. And here we can see no matter it's still running or closed already, right? So let me stop here and let me try to explain the life cycle of a container. So let me go back to my slides. So when I issue docker run command here, when I issue docker run command, it's creating and running a container, which are actually two separate processes. It's firstly create a container and then start the container. So technically, docker run in the command line, it's identical to a combination of two other commands together, which is docker create plus docker start. And let's see what's the difference between create and run. In the diagram, we've looked into several times. The process of creating a container is that we take the file system in there, which is step one, right? So we take the file system and kind of prepare it for use in the new container. So so far we're just talking about kind of preparing this file system snapshot to be used to create a container. to actually start the container, that's when we actually execute the startup command, which is step 2 here. That might start up the process like echo or ls, right? So let's test it out. Jump to my terminal again. Let me clean it up a little bit, and let's do let's use the old image, the simplest image, hello world, and this time I'm gonna issue docker create instead. Docker create hello world, and you can see quickly after I run this command, I got this long string printed out. This is the ID of the container that was just created. I can now just execute the hello world commands by running docker start. Let's do that. Docker start. And actually, for getting more detailed information, let me add these argument -a and docker command. Sorry, the ID of the container. Let's do that. Okay, here we can see it list out, as you remember, it's basically just print out this hello from Docker string, right? So let's see some difference, by the way. So Docker start without -a, and let me run that again. Okay, you see it just return, give you a result without these detail. Basically, -a just consider that is just attach what happened to your terminal so you can see what's going on, right? So now I think you can see some difference between Docker run and Docker start. Basically, Docker run shows you info coming out of the terminal. On the other hand, Docker starts without the -a argument is not going to show you those details. All right. So after we understood the lifecycle of a container, I believe it's going to be easy to catch up with other commands for restarting stopped containers or removing stopped containers. Let's go over those commands real quick. All right. Actually, I've already showed you how to start a stop containers just now. The point is, after a container is stopped, it doesn't mean that it's dead or cannot be used again. We can quickly start it back again by issuing docker start with the ID of the container. Let me do that again. Let me first issue docker ps and just confirm there is no containers currently up and running, right? And then let's do ps-a to show you all the containers that have been stopped on my machine. So I will use the last one example. So to restart this container, just issue docker start, and I use -a to so we can see what happened on my terminal, right? So docker start -a and with the ID of this container. And as expected, it should have showed you the string from this echo command will come to ztalk, correct? Cool. However, just please note here, when we have a container that's already been created, we cannot replace that default command as soon as it started up with that default command. So in this example, we cannot do something like start the container and then try to replace this default command. Echo welcome to ztalk to something else. Let's test it out. Docker start -a, right? So I'm gonna still use the ID of this container. So this time, let's try another default command. Try ls. So hit enter, and you see here it is return an error message real quick. You cannot start and attach multiple containers at once. That's very important. So basically, we cannot do something like start the container and then try to replace the default command. Once we have started up a container and let it exit, we can start it get back up again, which is gonna basically reissue the default command that was used when the container was first created. That's pretty much what I want to explain about the life cycle of the container. I think after this solid understanding of the life cycle, it will be extremely useful later on when it's really going down to troubleshoot and debug a running container. All right. Okay, so here I list out some most common Docker CLI commands that you will frequently use to interact with Docker. All right. So once the containers are stopped, how do we delete those containers to release the system resources? We're gonna issue docker system prune -a. This command does not just delete all the stopped containers. It also deletes the images that you download from Docker Hub. Just be aware of that because you're gonna wait a little bit time next time when you started up a container, as it has to re-download that image from Docker Hub. Let's test it out. Go to my terminal and just do docker ps, and you can see there's no containers running, and do a docker ps-a to show all the container stop containers. All right, so let's delete those containers by docker system prune -a and issue yes to confirm, y to confirm. And here we go. So you can see all the containers were deleted along with the images here, right? So now if you run that docker run command to any of the image, you're gonna re-download from the Docker Hub repository. Basically, let's try that out. What about docker run bzbox? Let's do again ls. You see, it shows unable to find image, and it's re-download from the Docker Hub, and then the command is like here. Show the ls command shows here. All right. So let me go back to my slide. Next one, Docker logs. Basically, it returns all the output from the container. Let's do a example. Let me issue this guy, docker ps-a. All right, so let's try logs, docker logs, and the ID of the container, this guy. And basically it returns the same thing, right? So that's basically will be these docker logs command will be really helpful. We'll kind of troubleshooting or debug the a container, a running container, or just container, right? So the next one is stop, right? We talked about how to restart a container. How about stop or a running container? It's docker stop or docker kill. The main difference between stop and kill is that docker stop gives the process inside the container a little bit time to clean up and shut itself down smoothly. On the other hand, docker kill issues a kill signal to the primary running process, so it shuts down that process like immediately. You do not get to do any additional work. This pretty much like how the command we issue in the in shell on Linux system operating system. All right. So next command is another important one. So how do we execute commands in a running containers? So we're gonna issue docker exec -it in container name and command. exec runs another command, and -it allows us to provide input to the container. All right, so let me test it out. So go back to the container. Let me start some container to have it up and running. Let's issue docker run busybox and ping Google. All right, so go back here. Let me open another terminal like docker ps. Okay, we got these running container. All right, so let's do something on this container by docker exec -it and the ID of the container, and let's do a pwd. Basically get the current directory, the path of the directory. Hit enter, and we got root, right? And do another guy that like docker exec-it ID of that command. Do a echo how are you. Here we go. All right, so here, don't get confused with the concept I mentioned earlier that you cannot change the default command after the container is created. In this case, the container is already up and running, and you did not change the default startup command. Instead, you just executed other commands in a running container. With this docker exec command, you can also get a command prompt in the container. This is the command you're going to use frequently anytime you want to poke around a container. All right, let's test it out. So let's do docker exec-it and ID of the container, and do bang shell. Okay, here you actually logged in your in that container, and you can issue whatever command in that shell. All right, and ping google.com. Here we go. Yeah. All right. All right, let's call it a day. We've gone through all the basic steps, I guess. Next session, we're gonna build custom images through Docker server, and we're gonna make a real project. Don't get bored. Things are getting interesting. All right, see you next time.
Alright, thank you for watching my video. If you think this video is helpful, you're more than welcome to leave any comments. Remember, sum up, subscribe my video, and also hit the notification bell. See you next time.